can start with you, Mr. Adlakha. If you can first talk about what your company is doing in the CBG space very briefly and what the projects that you're currently working on.
I work as a Chief Operating Officer at REnergy Dynamics, and we are both an EPC player as well as a developer, where we invest our own money into projects. Currently on the CBG side, we are working on a few projects with Reliance and with one of the panelists here, which is Refex, right? So we're doing a couple of projects for them. And other than that, we are also developing a few of our own projects. One of them would be the largest MSW handling project in India. So that's something which is work in progress for us at the moment.
Could you tell us the capacity of the project and the location for these?
So largely, yeah, so these are all varying between, let's say, 12 TPD to 22 TPD. So that's what the project sizing is. The one which we are developing on our own is going to be about 46 TPD of gas, right? Which is based on MSW. Almost about 1,000 tons of MSW is going to be processed there. Yeah, so that's what the.
And what would be the location for these
locations?
Projects?
Are like, so the ones with which we're doing with Refex right now, those are in Tamil Nadu. Whereas the others one with Reliance are, one is in Maharashtra, one is in UP, and one is in Gujarat, and one is in Bihar.
All right, thank you.
Yeah.
Mr. Bhattacharya, same question for you, the projects that you are working on.
Right, thank you. Good morning, everyone. I'm Abhirup, and I work with Gruner. We have around 17 projects that is currently under commissioning, most of them. Few are completed, producing gas. They are all roughly around 21-22 tons per day, except the Prakasham project, which is 25 tons per day. Now, I just wanted to say that these numbers, these rated capacities are something with which we design the projects. But actually these plants, if operated properly, can produce much, much more. The recent example is we completed our Satna project, which was a 21 ton per day project. And we could run it during the PGTR process at 23.5 ton per day. And we could have touched 25. Unfortunately, there was a storm on that day and with some electricity failure. Having said that, so now most of these plants are of Reliance. And what Reliance has realized is our technology is something which can be expanded or rather debottlenecked. So we have received orders from Reliance to debottleneck all these projects to 27 ton per day. So from 21 to 27 with minimal expenditure, these projects will be expanded. So that's where we are. We are doing projects for other clients as well. Quite a few corporates, some of them are present here. So that's where we are, sir, and then we can.
Okay, thank you, thank you. Mr. Kumar, Mr. Kalpesh Kumar, your portfolio in the CBG space.
Thanks for inviting. My name is Kalpesh Kumar. I'm Managing Director of Refex Renewables and Infrastructure Limited. We are a diversified group, but talking about the renewable side, we are into biogas, solar and wind. On the biogas capacity, we have acquired 2 plants, one in Kolhapur, one in Vizag. We are running or working on 4 projects in Tamil Nadu, all MSW projects in Coimbatore, Madurai, Salem and Trichy. The entire capacity would be around 50 ton if we club together. Thank you.
The cumulative capacity is 50 ton, or the
output, I'm saying.
Okay. And what's the capacity like for the individual projects?
So Coimbatore is about 250 ton input, Madurai 250 ton input, Salem 200 ton. The Trichy is around 120 tons. The operating capacity which we are running 220 ton in Kolhapur and around 70 ton in Vizag.
Right. Thank you. Mr. Kumar, I've already introduced you, and in the first round of questions. We're just talking about the portfolio, the projects that you have worked on, the capacity, location, and any ongoing projects.
Right. So, good morning, all. We have one project in Punjab, which is the first as well as continues to be the largest agri-residue-based plant of the country. It is 100% paddy straw based, having a capacity of 33 tons per day. So that's the portfolio we have. But I'm surrounded by EPCs here, right? So in our case, what is different is that we do our own EPC. So it is not a third party. So the complete, we are the investors, we are the owners, developers, operators, all of it, right? So this is what is a little different from the rest.
All right. Yes, Mr. Pathak.
Morning. I am Sankalp. I am representing GPS Renewables. GPS is a TEPC as well as through our development arm area, we are also developer for the CBG projects. As of now, we have completed 17 plants for our client Reliance, which are mostly biomass based, and we are operating them. Plus, we are taking up O&M for third-party plant, and the first large-scale CBG plant we built was Indore for Indore Municipal Corporation as well as Enviro, which was initially designed for 17, and now it is being operated at 21. So currently we do not have O&M, but we have built and handed over. And other plants we have done TEPC. We have our own technology for biogas plant, and then EPC followed by O&M we are taking care. Plus, we are building our own plant through JV partners with OMC, oil marketing companies, and these plants are coming into the operations. So most of our plants are in the range of 15 to 22.5, again, a nameplate capacity with possibility to increase the capacity further. Thanks.
Thank you. Mr. Khaire, your services for the industry.
Sorry?
No, Mr. Khaire, your services, technology services that you bring to the industry.
Good morning, everyone. Thank you for inviting. Here I am representing company Envirogen Energy Solutions. We are just a 2 years young company, and we are not into complete EPC, but we do a high pressure side or the downstream side of the EPC plant. Right after your purifications, we are into your PESO, right from the PESO area, which has been approved by the PESO. We do all engineering, designing, we take care of all the norms of the PESO, and we do a complete EPC of that, right from compression, cascades, tubing, fittings, fill post, metering, fire and safety, everything. We have been associated with Kirloskar Pneumatics for the compressor, for compression purposes, and then we have got association with SV Gas for authorization systems. So this is, presently we are working on six projects. We have already completed 2 projects. A few we are doing in Punjab, we are doing in UP, and a few in Gujarat. This is presently what we are working on.
Thank you. Mr. Adlakha, coming back to the projects that you mentioned in Tamil Nadu, Maharashtra, UP, Bihar. So could you tell us the feedstock? What's the feedstock for these projects?
Yeah, so it's so we are dealing with multi-feedstock at most of these plants, right? So we're dealing with MSW, we have paddy, we have Napier, we have cane trash, we have cashew, cow dung, press mud. Yeah, so most of the plants are multi-feedstock plants for us right now.
And for which location, like for which particular project, could you please tell us what?
So most of the plants which have been designed right now are for multi-feedstock, right? So it's across. The other ones other than that, for what we're doing with Refex, those are MSW specifically.
And what kind of arrangements do you have for feedstock management? Are you doing it yourself or with
So the feedstock at some places, at most of these places, given that these are EPC projects, these are being organized by the owners. So example with Refex, they are the ones who are arranging the feedstock. At the other plants for Reliance, they're arranging the feedstock right now. But for the plants which we are developing, like for example the project in Andhra Pradesh for MSW, which is the 46 TPD project, there we have a tie-up to kind of source the feedstock, the MSW on our own. So that's what we are doing right now.
All right. And with respect to different feedstocks, is it possible for you to share your experience with respect to the efficiency?
Efficiency actually varies. It's very seasonal, right? So really wouldn't be possible for me to give you a figure in terms of what the, let's say, the efficiency or the yields are right now. But I can only say from a technology perspective is that the learning for the last so many years for us has been that don't design the plant with just one feedstock in mind, right? Just make sure that it is flexible enough to process 3 or 4 different types of feedstock, because it's highly unlikely that you will get one desired feedstock for the entire year. Very difficult, right? And therefore, whatever technology interventions on the pre-treatment you need to make sure that you have the requisite machinery to process that feedstock right from day one. And that has been the major learning in the last, say, 1.5, 2 years for us.
And is it, what has been your experience with these technology players for these pre-treatment plants?
So again, in that, it's been a learning experience, right? So if you say that the product, what we bought at the start, did it work 100%? Well, the answer to that is no. It had to be kind of evolved into something which worked for us, right? And worked for the industry, right? So like for example, for paddy, which we use extruders, right? The extruders have also gone through version changes. We buy them from Steer right now, but the Steer product, which started from day one to what is it today, is very different, right? It has gone through its evolution, right? So most of these products have also learned. The shredding solutions, etc., what we buy, those have also evolved over the last 18 or 20 or 4 months also. So it's been an evolution, but we're getting up to a point where we see a little bit more stability in technology right now, and that should really be good for the industry.
And these technology players, are they Indian, domestic, or global?
Our preference is Indian, because the feedstock characteristics, what we get in India is not what we get globally, right? For example, the MSW which is coming in, the municipal solid waste, right? Overseas, it just might be segregated organic waste completely, right? When we get segregated organic waste, it's not 100% organic, right? There will be metal parts, metal fragments in it, right? So there is a lot of adaptation which one would need to do for the Indian side of what feedstock is available, right? So that's something which everybody has learned. People are still learning. People are still trying to figure out what works. But yeah, we are almost like 75-80% there in terms of what we need to do now.
Thank you. Mr. Bhattacharya, why did you select the location? You shared some of the project, the Satna project as well. What was the preconditions for that? What was the strategy that you had before selecting that location?
Okay. Selecting the location depends on, before that, let me say that this biogas business is actually a supply chain business, right? So effectively, how close you are to the feedstock and the multiple feedstock that Mr. Adlakha was talking about, it is a must. So we need to be close to the feedstock. There needs to be tie-up with the customers, and by customer, I mean the farmers are our stakeholders here. Because they are giving us feedstock, they are also taking form and L form. So there is a mutual, buyback which is taking place. Also, are the retail outlets or the CGT network for the CBG, CGD synchronization nearby? So these are the factors which makes the location of the land selection a priority. Also, the land needs to have a soil bearing capacity of at least 18 kilonewton per meter square. Otherwise, you saw Keller's presentation in the previous segment. You need to get into stone piling, heavy piling. Cost will increase, make it non-economical. So this was one of the factors. And you need to be on the highway. A lot of vehicle movements will take place. Cascade movements, L-form movements, form movements, right? So accessibility is must.
And you talked about, I think, around 70 projects that under construction or in advanced stages. So what is, if you could share us the feedstock profile for these projects?
Well, see, these projects are all sprinkled across UP, Madhya Pradesh, Punjab, Gujarat, Maharashtra, Andhra Pradesh. So the feedstocks are completely different and it depends on the state. I can tell you in some of our projects, the feedstocks, we use as many as 13 different types of feedstocks. Right? I can list them out for you. We use paddy, we use cow dung, we use bagasse, press mud, molasses, corn syrup, some chicken litters, cakes, DOC what we call. So there are almost 13 different types of feedstock. We also use Napier, depends on the farmer's produce. So the digestion is important, because the digester needs to digest the feedstock. It is not always that the cheapest feedstock is the most viable one. I actually call it ABCD of the feedstock. A being availability, B being biologically stable, C being contractually, sustainable. You should have signed contracts long term with the farmers, right? And the D being, it should be digestible in the digesters. So if you take care of this ABCD, your plant should run perfectly.
And the states that you mentioned, UP, MP, Punjab, Andhra Pradesh, so which states have good CBG policies, and did you get any incentives? And what kind of incentives did you get?
Okay. As far as incentives are concerned, we being in the LSTK space mostly, the incentive goes to the clients, right? But having said that, the states which have got the best policies are UP, Maharashtra. Jharkhand is coming with a perfect policy, which is on the, but but the most important is the central government policy, which was being discussed in the morning. That should take care of the business completely. Like an IRR of 18 to 20%, what we are getting right now, I'm talking about post-tax project IRR, it will just jump to 31% once that policy is in place. So this is a happening place to be in the time.
And if not incentives, like what other things that you need from state governments to make the entire construction process easier?
Okay. So there are certain incentives which the state governments have provided. The SGST has been waived for a particular period of time. Right. Some states have given income tax exemptions for a few years. The land is being provided at a lesser lease rate, which makes it quite good. The state governments are also now in discussions with the agro feeders. Actually, we are in the aggregation of the agro feeding also. So our company Kisani does that for us. And in fact, for many of our customers, Kisani is doing it for across India. So the government supports this venture because it's a mutual win-win situation between the CBG company and the farmers in the vicinity. So this is happening, but frankly it's not happening in all states. I can see it happening in Maharashtra quite a bit, MP and UP. These are the three states which are leading right now. The rest of the states are following. Andhra Pradesh, by the way, are trying to do quite a good bit of it. They are moving the tribals from different areas, trying to put them at a location called Prakasham. So Reliance has got a huge tranche of land being given by the Andhra Pradesh government, and they are going to develop that, tribal belt-based, Napier-based CGD.
Right. Mr. Kalpesh Kumar, you've had good experience in the financing sector as well. So your viewpoint on the issues that developers face while financial closure, and what kind of requirements do lenders have, and what are the key challenges there?
There are many challenges. Bankers are already funded lots of CBG projects, and they are able to see that most of the projects are not making money. So when a new proposal come, if the bank has not funded, it's easy. If they have funded, then explaining them become very difficult. The technology has also changed. So and the MNRE subsidy which was available earlier, is yet to come back, that we are hoping. But bankers are quite understanding that the sector is very challenging. So they mostly taking a call on the group which is putting up the project. So for us, we are large corporate. So they are taking a warranties and guarantees from the corporate holdco to make sure that if in case there is a project is not making the investment or the payment, then it should become from the top. That's a one risk we are looking. Second, the challenge is that bankers have not seen the cashback coming back to them from the existing projects. Subsidies always been dependent, so they don't consider subsidy as a repayment schedule. They may give some money, but not fully. So again, that subsidy money you have to bring upfront to get the money from your equity to get the project funded. Feedstock is challenge. So broadly, bankers are aware what are the challenges, and it's becoming challenge. Off-take agreements are not getting signed. That's also one challenge. GAIL and the other IOCL are wanted that they have already given a 3,000 plus LOA and project has not come, so they are waiting for developer to do some project at the ground. Then only they are coming ahead and signing the PPA the off-take agreements. So this is also one challenge, because when you are going to bank, you are saying that the off-take agreement will happen versus you have an agreement in place. This makes a different thought process to the bank.
So for the renewable energy sector, like we know there are around 44 gigawatt of projects which have been commissioned or are underway, but the PPA, PCA have not been signed. So in the CBG space, do you have an idea how many projects are there for whom which are ready but off-take agreements are not being signed?
No, there are many. There are many. So leave 6 months from, if you go backward, up to last 6 months, the IOCL or the GAIL is not signing agreement, but before that they were giving the LOAs. So there are 3,000 LOAs already been given, and those projects are not funded. The operating assets, what we have right now, it's near to 200 or 224, if the MNI data, if I look at it. But rest of the projects are not funded, or it's still in the pipeline.
So the construction has also not started?
I'm sure it was not. They have just prepared a project report, might be acquired the land. Some agreement with the feedstock is done. 100% EPC is not closed, or if it is just closed, then nothing has started. Without the banking, it's very difficult to start.
And with respect to, is there any, for the existing projects that have commissioned or which are underway, are there any delays in execution delays or time overruns, cost overruns?
Within the boundary, I don't see much challenge. The only long lead item is, I think, compressor. Digester people are able to make it quickly. So the dependency on others is quite less. So I don't see there's a challenge in executing the project unless some critical equipment you are not getting. But if you have funds available, execution should not take much time.
And when you said that banks are concerned that the projects are not able to earn money, so what is the main reason behind it? Like they're not able to get off-take agreements on time, or the selection of technology wasn't right, or the feedstock management isn't right? Like what are the main reason for the project not earning money?
So multiple reasons. Let's start with the feedstock. Whatever assumption people do at the time of submitting the documents, then the feedstock is not available. Especially people who have worked with municipal corporation, they have faced a lot of issue. On paper, we have a agreement wherein the municipal corporation is supposed to provide 100 TPD per day, but they are not giving. And if they are giving, it's not segregated. So that's one problem. If you go ahead, then the efficiency, what you assume at the time of banking closure, for press mud around 4%, for MSW 4.5%, those numbers are not coming. For paddy, people used to think 11-12% yield to come, which is coming in few plants now, but not all. So that's also a challenge. So you have efficiency challenge. And in some places there are offtake issue also where the nearby CGD is not there. They have to send their vehicle quite far. So the cascade availability is less. They have to buy more cascades to make sure that transition happen properly. So these are the broad challenges on which numbers are not coming.
All right. Mr. Kumar, coming to you with respect to the offtake agreements and about the issue about projects not making money. So how much he talked about feedstock management and yield, and what is the role of pricing of CBG? Do you think the current model that we have, 85% of the CNG benchmark price, is it sufficient or less, or what should be the change in that to make it more bankable?
So I was wondering, what are you going to ask me? Because all interesting questions are over. But this is probably the most important one, right? The current price is definitely not enough. You can't have a biofuel being sold at a discount to a fossil fuel. Doesn't make sense. We get paid 85% of the retail selling price of natural gas. So simple answer is this is not sufficient. This translates to about $17 per MMBTU, right? If we are really serious about taking the CBG sector ahead, then it has to come to in the range of about $30 to $35 per MMBTU. And I'm not talking about the gas price, I'm talking about the consolidated revenue stream, which is coming from both gas as well as from the manure. Right, so I'm talking about the combined revenue, and I'm not including any revenue which should ideally come from the carbon monetization as well. Right, so these are the three revenue streams which any CBG player should be relying on, so that my IRR is also, as my friend said, 18 to 20%. The developer's IRR is less than 10%. पैसे कोई और कमा रहा है. Right? So if we want to see anything north of 20%, that can happen only when you have all the three revenue streams. It doesn't come with the current revenue stream.
And what were the three revenue streams?
Gas, manure, and carbon.
And all this included should be around 34?
No, gas and manure consolidated should be about $30 to $35. See, if you look at the current revenue stream, $17 you get from gas.
Yes.
If I include the cost of compression, it will be about $18 to $19. Today, you get a MDA of 1,500 rupees per ton for the fermented organic manure. So if you convert that also, so we are roughly around $24 to $25. If I combine both gas and the manure, FOM, LFOM combined, right? So there is a delta of about close to $10 which needs to be bridged. Now, whether that is bridged by way of pricing or by way of capital subsidy grant, it depends on how you want to channelize the capital. But unless that happens, I think your previous question was how many plants are there. We have 210 operating plants as of now, right? So वो ज़्यादा नहीं बढ़ेंगे जब तक ये नहीं बढ़ेगा.
Yes. So the problem is, like, we've talked to these OMCs as well, and we have a session with OMCs after this as well. So we've asked the question about this increasing the pricing, and they obviously don't seem to be that keen. So how do you?
But they are not the decision makers for this, right? So it is not being determined by oil and gas marketing companies. Ultimately, it is got to be at a higher level. If we are looking at energy security as the broad theme, this has to be a call which has to be taken at the ministry level. Because the current investment business case is not a very bankable business case. So all your previous questions, whether it is related to financing, these are not bankable projects, irrespective whether we talk about the feedstock availability, feedstock pricing, lack of offtake. You need to give a good price right? I can't expect the government to do everything for me, but I'm expecting a good price. And then, yes, then it's my part of, it's my business and I should know how to manage it. I mean, I can't expect the government to provide me bailers also and capital grant also and MDA also and everything and still complain about it. I'm just expecting the right price.
And if you get a very good price, then all these capital incentives you are willing to go away with, or
Yes,
even that.
absolutely. I mean, you should have the least of the dependence on subsidies. You're looking at two things. One, at a capital level for the capacity build-up part, and second, at the price of the product. This is how simple it should be. Now, anything on top of it, if you are able to make by way of monetizing the carbon or by selling the manure, enriching the manure, that's, on top, right? But then there is no further assistance expected from the government.
Right. And one last question, then we move to the next panelist. You talked about increasing the price, increasing the revenue, but what is, in terms of costs, what is the one aspect in which the developers are inefficient in, and the cost is very high, but it should be reduced going forward?
Sorry,
The cost of production.
The cost of production, it
Which-
should be reduced.
Which is the part of the entire project in which developers are little inefficient in, and the cost is high, but should be reduced?
See, I mean, basically, you're looking at four cost heads, right? There's a feedstock cost, right? That varies depending on what feedstock you're using. But to give you a little precise input and not very generic input over here, let's say if you're talking about paddy, right? Your cost of paddy farm to feed is going to range anything between 2,500 to 3,500 rupees per ton, right? Now, depending on whatever efficiency you're getting, let's say we get an efficiency of about 11 to 12% consistently on paddy, right? So that is my basis of the feedstock cost. Then on top of that, you've got maintenance, plant maintenance, energy cost, and manpower cost. These are the four broad cost heads, right? If I total all of these up, I think the number would be roughly about ranging between 65 to 75 rupees per kg of CBG produced. Right? Abhi इन चार cost heads को optimize करने का scope is almost negligible from my point of view. There could be a plus minus 5% here and there, because if we are kind of expecting that CBG is going to go the same way like other renewable sectors do, that is a very wrong, impression. This is going to remain flat or even higher, because the feedstock cost is going to grow. It's going to increase and it's not going to go lower. The energy cost is what you pay to the state electricity board, right? So we are dependent on what prices are over there. So for making every kg of gas, you would, I think, under a stable state, you will spend about 3 to 3.5 units of electricity. So if I am in Punjab, 8 rupees per unit, so you are spending about 20 to 25 rupees per kg, right? 25 रुपए यहाँ पे 30 से 35 रुपए feedstock के 60 रुपए हो गए, right? Then you will spend some money on manpower and some money on the maintenance bit of it. That's how I came to a bottom-up calculation of about 70 rupees plus minus. We have not included financing cost, right? So on top of it, so this is purely EBITDA level, right? Now, if you are looking at a PAT result, so now come back to your first question, how much is the current price? We get about 72 rupees X works for gas. So if there is no money coming, no money coming from FOM, then we can all shut down our plants and sit.
Right.
So that's the rationale to the expectation of $30 to $35 consolidated.
All right. Thank you. Thank you. Mr. Pathak, you've had experience across 15 CBG projects you are currently operating. So what are the key learnings from that, especially in terms of engineering, design, and what are the common mistakes that several developers make in the engineering side of things, and what are the best practices that the developers should follow?
Yeah. Okay. So I will start with from input material, then pre-treatment, biogas digester technology, BUU technology, biogas upgradation technology. So that way we will look at it. So first thing, like everybody agrees on this panel, is they're going to be multi-feedstock plant. So even if we plan to build a plant only on paddy straw, our approach and our experience for last 3.5 years is it is going to be a multi-feedstock. It is a commercial plus technical decision what kind of feedstock available and when it is available. So the input system has to be robust enough so that it can take multiple feedstock. Broadly, we distribute them into agro waste where TS is above 70-75%. Then high moisture content feedstock like paddy, PMC, cow dung, which don't need much pre-treatment and can be added directly. Then it comes MSW, which is also high moisture content feedstock. But it needs a lot of pre-treatment. And last one is somewhere in between like bagasse, which don't need pre-treatment but also do not have a lot of moisture. So except for MSW plant, all the biomass plant what we have built are able to handle all this feedstock, and that's how we are operating the plant. And next, coming to the digestion system, for MSW we prefer two-stage mesophilic. For all biomass plant, we are going ahead with thermophilic CSTR system. So in that, we are operating multiple feedstock. We have seen the system is robust enough. Some benchmarking we are able to do where we can produce somewhere between 5 ton CBG per digester with volume of 6,000 meter cube plus minus. So these are the benchmarking exercise we are able to do with our experience. In terms of SLS, so see whatever input material you are putting in, the plant has to be operating in balanced condition. The solids, volatile solids, moisture content I am putting in need to be taken out. So volatile solids has two output. One it goes as a biogas, another one I have to remove in as a solids from the plant. So for that we have zeroed in on two-stage solid separation, screw press followed by decanter, which helps us in operating the plant in balanced condition. And coming to the BUU, we feel that that is more or less sorted out solution. We have zeroed in on H2S removal system followed by membrane-based upgradation system. So we have developed our own DuTech pack. We have filed patent on it, which makes gas suitable for input to the membrane. So with that, we have seen membrane system works well. It gives designed purity as well as designed recovery. It has been established all across our plant. So that's how the current technology landscape we are looking at. Again, I just missed one point in terms of pre-treatment. So for biomass-based plant, we see need for two-stage pre-treatment, which shredder to make material up to 50 mm or slightly larger, followed by extruder or hammer mill. So both in that hammer mill, I feel more or less matured, but extruder work is going on, so it will get certain maturity in coming days. Regarding challenges, there are few challenges, and going forward we are trying to improve on that. One is the HRT concept. So what happens, the HRT concept has come from the wastewater treatment where water is being treated. But in case of biomass based plant, water is just a carrier. All the liquid we taken out of the digester, we are feeding back to the digester again. So we are coming to the point that we are focusing more on achieving higher SRT, solid retention time, than focusing on HRT. For that, new advancement we are looking forward is better agitation system. We are introducing paddle agitator in our new plant. Before we have side entry agitator. With paddle agitator, we planning to operate plant at higher TS so that SRT can be improved given in the same digester volume. First learning. So accordingly, we are also engaging with SLS manufacturers, screw press manufacturer to handle higher TS. Second part, what we learned is in case of paddy straw or biomass, the H2S content inherently is low. But the H2S concentration depends upon the water quality. If water has higher sulfate, it translates into higher H2S. So that has to be taken care at the time of design, what kind of water available. So it will decide what kind of H2S removal system you need. If concentration is higher, we have to go something like ISET technology, which we are going ahead. And then coming to the latter point, like as the number of plant increasing, we felt a need for more of a comprehensive view of the plant. So we are focusing more on digitization and advanced analytics, where we can operate multiple plants from central location, because getting a trained manpower who understand the bioprocess and biotechnology and the biogas in all the location, we find it difficult. So solution we come up with, we aggregate the data at central location in Bangalore, and we have our own bioprocess team which looks at the data, and plus all the plant we get consolidated view. Let's say we are operating now 17 plants. So all the plants we see in a single dashboard, there are automated alerts generated. So those pass on to our site team, O&M team, as well as site technology team, and they take corrective actions accordingly. So these are the learnings we are trying to implement as we are operating current plant, as well as going forward we want to operate.
Yeah. Thank you. Thank you. Mr. Khaire, you've a solution in the downstream side of business. So what are the key inefficiencies there that developers often overlook, and what are the technology advancements now available that solve those inefficiencies?
Specifically to downstream, if you're talking, moreover, what my experience says that people think that it is just a purchasing of a compressor, take it from whichever is the good vendor from the market or who is giving the cheaper one, or purchasing a cascade, whoever gets the cheaper one, and it becomes that simple. But as per our experience and whatever we have seen so far in the field, it is not that simple from the day one, because still our plants, whichever has been built in India, are not been that old, or we don't have many plants who are 5-year-old or 10-year-old. So things we have to take care in this high pressure side is right from the beginning, having three aspects. Like one is from the statutory point of view, like your PESO explosive things and your fire safety norms. Another thing is like the selection of right equipment, right quality, right capacity, right from the compressors or the storage capacity we have to have in the plant, even from the sizing of the tubing, piping that we are using. Even when we are synchronizing with the CGDs, we are selling the gas from the CBG to the CGD, there has been the issues that we have seen that the equipment or the cascades or the end connections that CBG suppliers are supplying is not been acceptable to the CGD. Then they will go back and they will say, oh, you change this to the whatever is required by us. And the third aspect is the operation and maintenance aspect. Because operation and maintenance aspect is going to be a very crucial aspect once your machines start getting older. When more operations happens, and then we have to spend, it will be a cost aspect. What sir was mentioning, that your cost has to be into the control, then your operation and maintenance cost has to be in control. So these were the three aspects that what we have so far seen, and we have to consider from initial days. Before we start planning your plant, we have to have these aspects in.
Thank you. Thank you. Mr. Adlakha, maybe a little more details about the EPC side of business. And in the morning also, we've had some discussion on the ideal project size. There was some talk about it in the presentation. So you have projects in the 12 TPD to 20 TPD space. So is there any capacity range which the industry feels is bankable, and projects bigger than that or smaller than that are not?
I think what we have analyzed so far is that if you really want to make the costs work and kind of give the equipment which the plant requires, right, to process waste and to make sure the gas is being produced, it should at least be a 10 or 12 TPD at the minimum, right? Otherwise, the cost start to kind of mount up, and the per unit cost of gas, which you're going to be loading onto it, is generally higher, right? So if you really want to have efficiencies of scale, you should at least have 10, 12 TPD of a sizing at least, right? Now, to a large extent, it also depends on. Is it something I can treat it in isolation? The answer to that is no. It really depends on what feedstock I'm going to get. What feedstock? Is there a seasonality of the feedstock, right? How much of that feedstock can I store, right? What would be the degradation of that feedstock when it is stored, right? How much do I lose in terms of its efficiency and in yield, right? So I'm saying those are the additional considerations other than simply my saying that, look, I would want a 10 TPD or a 12 TPD plant. So those are something which I would really consider when I'm going to be looking at a plant sizing.
And with respect to the timelines, if you could tell us what kind of timelines you have for the project commissioning and what is the timeline for each stage of the project?
See, I think from an overall perspective, I think it's a good back of the envelope number would be about 15 to 18 months to kind of commission a project, right? And that is including land development as well, right? So it typically takes about 6 to 8 months just to kind of make sure the land is prim and proper, right, in all respects, right? You have a boundary wall, you have done your geotech, you have acquired the land if you're a developer, you have taken the requisite permissions, right? And each state today has a very different process of getting those permissions. Some give it much faster and some take a lot of time as well. So if I was to have one suggestion for enabling this entire industry is to streamline the process of approvals across every state, right? In a state, you might take 6 months, in another state, you just might take 2 months, right? It just makes that much of difference to time to market for your gas which you're going to produce.
And in the states that you are currently developing your projects, in which states it's easier?
So as has been said, so UP is a good state to be in, Maharashtra is a good state to be in, right? Andhra Pradesh is a good state to be in, right? But again, as I said, so there is on one side, there is the subsidies and everything which you get from the state and which you factor it in, right? There is obviously a question mark on the timing of that subsidies when you would get it. But I think the more critical part of it would be in terms of, as was rightly said, that in terms of how far is it away from the gas offtake point, what's the feedstock, how soon can you get the feedstock without degradation to your plant, right? I'm saying those are, so when I would look at a state, yes, there are policies and benefits which are being given, but I think I would rather look at it a little bit more holistically, just rather than relying on the subsidies. If given to me, left to me, I would probably say that we should design a subsidy-free project, if it works. Right, and that's to Ashish's point, right, that, yeah, 72 or 75 is actually pretty less in terms of one wrong step or one escalation on the feedstock is enough to kind of destroy the viability of the project.
And after these 6 to 8 months of time that can take for land acquisition and land processing, after that?
Yeah, it's pretty much standard. Then once you have a boundary and you have an unrestricted area to work on, pretty much 8-9 months is good enough to kind of get it done.
And with respect to talking about 10 to 12 TPD of a minimal capacity, then what about these decentralized small-scale CBG projects? How do they become bankable?
So they become practical. See, most of these decentralized projects today work on cow dung most of the time, right? Or on vegetable or food based or anything, right? So those are good enough, right? But I'm saying if you really have the industry has to scale. It necessarily needs to have larger projects, 10 to 12 TPD and higher, right? And the plus point is that if you look at it a year back, we didn't really have much of an ecosystem, right? Today we have that ecosystem. There is a lot more standardization in the industry today, and people know what equipment to use, where to use, how much is it going to cost, right? But as I said, that look, it's an evolution. So if we really have to meet the government's target of 5,000 plants by 2030, I think we are still a long way off. 200 plants really doesn't cut either ways.
And
you have one comment on a smaller scale plant. Wherever there is a feedstock is a challenge and people are paying to discarding the feedstock, On those places, going for a smaller 1-ton plant in a housing society, all it works. But on an industrial scale, Shashank is right.
Okay. Thank you. You have a comment on that?
No, I just said, so I'm saying that the, and I have worked in the renewables industry for a fairly long time, right? And I can just draw a couple of more parallels, right? So one is that, look, and the same holds true for biogas as well, right? It is one part to kind of put up the plant, right? So if people think that's the hard work and it'll be very easy to run the plant subsequently, the answer to that is a big no, right? If you just quantify the efforts, right, out of 100%, in my opinion, right, 10% is the effort which takes up to develop and put up a plant, right? 90% of your effort is actually in running the plant, right? And we're running 3 or 4 plants right now, and it's a daily, every minute, every hour, every day, every week job, right? You take your focus out for even 1 hour a day, and the plant starts to struggle in gas generation the following day. So to me, I think the biggest risk for the industry is not about putting up those plants, right? The plants will get put in, you'll be able to factor in the cost, right? But how do you then run it very efficiently for the next 15, 20 years, right? And that's going to be the key. And one of the other things which we have learned, and maybe I'm just digressing from the question which you raised, is the lack of manpower to run those plants, right? We simply don't have it, right? And I don't think not enough is being done to kind of get over that hurdle right now. We've just kind of, whenever we try and hire people for O&M work, invariably there are people who are coming from another operating plant who apply for these jobs, right? All they expect is a 10 or 15%, 20% higher compensation. So what we're doing, we are increasing the cost of maintenance, right? But we are not widening the consideration set for getting in more people into the industry. And that's where I think the biggest risk lies. Fine, we might get to 500 plants, 600 plants, whatever that number might be. But I think until we overcome this people challenge, right, it's always going to be that cost which, like Ashish said, that we should get a higher cost, right, maybe 8,500 rupees or whatever that cost might be. That will still prove to be inadequate. Because the cost of people, right, is always going to go up. And we don't have those many people in the industry to work on these plants, on the operations and maintenance side right now.
All right. Thank you. Mr. Bhattacharya, about again, coming back to the pipeline of projects that you have. And when you were planning these projects, so we talked about the different revenue streams, about gas and manure. So is FOM monetization, like how much is the percentage of that monetization in the total revenue that you have envisaged? And what is the plan in the FOM monetization space?
Okay. Let me address that in a little larger perspective. Particularly, first of all, let me rebut a little bit in what Ashish was saying. Our experience had been a little different. And I'm not talking here about the LSTK financial model. I'm talking about the financial model for the client. Right. So in our case, the total OPEX is around, let me put it like that, it's around 44% will be around feedstock. 26% is electricity. 9% is manpower. I'll address the manpower issue also, what Mr. Shashank was saying. So roughly, what it turns out to be, and then there is a maintenance component of around 16 to 18%. So we have to address each of these components independent of the others, which means we have to do something for the plant to improve the digestion. For the paddy yield of 11 to 12%, we got around 13.5%. not consistently throughout the year. It needs to be seen whether it is consistent. How did we do it? Our digesters have paddle agitators. Multiple locations we have inserted sensors, which are VF analyzers, pH analyzers online. Right? We feed in all these and also the agitator motor currents into our CFD software. So the CFD software tells us if there is a localized mixing not taking place. In a nutshell, this is a pretty complicated thing, but having said that, what it also tells us is what feedstock not to add. It gives us the recipe for the feedstock for the next day or the next week. So instead of poisoning the digester, instead of increasing the VFA load, which in turn means that 8 to 10% of your methane does not get produced, we take care of it earlier. So we get more yield. That is one. The second thing, what we do normally in our plants is the manpower. The manpower, normally these plants need around 21 ton per day plant will need around 100 manpower, 102 manpower. We run it at around 75. We intend to bring it down to 20, all shifts taken together. Now, how do we do it? So the plant has to be run on auto. It is just like a pipeline. Now, believe me, when we were telling one of the clients, Reliance, they were not believing. They were actually quite skeptical about it. These plants can be designed in a batch process. These plants can be designed as a continuous process. Our technology we designed is in a continuous process. It operates like a pipeline. You just put in the feedstock, stable run the equipment. The moment you run the equipment in a stable way, your maintenance cost comes down. The frictions are less. Your extruder maintenance goes down, which is one of the humongous, cost-bearing place. The digesters run smoothly. You continuously produce gas. You have to take care of the LCVs on a consistent basis. It should run without stopping. Every day we take a half an hour shutdown. That's it. Morning 6 to 6:30, half an hour shutdown for maintenance purposes. All maintenance, it's just like a car rally. Those pit stops in the car. So they just get a minute pit stop. We take a half an hour break. So our maintenance teams are trained to grease all the 24 greasing points in a layman extruder. In one extruder, you have 24 greasing points. All the 48 greasing points in the walking floor. So our entire technology is based on a concept where we run it as a continuous process. It's quite stable. I'll tell you my cost. For a 21 ton per day plant, it's roughly 60 rupees is the OPEX. So with 72 rupees Satat rate, our client is still making money. So only thing here is we need to ensure that we only do not dose the expensive feedstock. Paddy is expensive, 2,700 rupees per ton. You mix it. The fiber is important, but you mix it with liquids. Put in industrial waste. But the industrial waste will create foaming. It will also reduce the pH. You have to manage it properly. That is the key. And that is the key. If you run the process in an automated way, our CFD simulator does that exactly. It tells me when to stop paddy, when to add the industrial waste, when to add molasses. So those things are very important. Those mix of recipe is very important for the plant. You need to operate it in an optimized way. That is what is most important.
All right. Thank you, Mr. Bhattacharya. Mr. Kumar, maybe the FOM question you can talk about, because I think Refex also has a bio-manure, biodhanic. So what is the, what's your distribution channel there, and how do you deal with the farmers, and what's the supply chain like for bio-manure?
Thanks. FOM is critical component for making the plant profitable. especially from the press mud, the quality is quite good, and the farmers who have been earlier using also press mud, they were storing it for 6-8 months and they were using it. With this fermentation process, the product become much better. For us, we have a plant in Kolhapur, and that area where we have plant is near to the agriculture belt. So we have seen that there are farmers repeatedly coming to collect the manure from us. So we decided to launch our own product to, and put some upgradation of the product, added more NPK to make sure that the people who are buying the manure get the results. We also done few trials with the KVK Kisan Vigyan Kendra. We done with some FPO to see and measure the output which is coming from the manure and the liquid which we are selling, and it's been very good. I'll give you one example where in KVK they have tried on a coconut tree. They were finding fungus coming every time to the coconut tree when they were using chemical during the process of cropping and taking out the coconut. When they have used over LFA and FOM in the process, they have realized that in two places where they were using chemical versus LFM, the fungus was quite less. So basically, the outcome was that the immunity of the tree has become much better to fight with the fungus compared to the chemical one. So there are multiple such trials we have done to make sure that our product is quite useful, and there is a product validation which we can give it to the farmers. And this is a part of the revenue stream, and if you are able to get it proper, I'm sure the target of 32 will become near with a higher price.
And how do you care about the pricing? Because there's concern that chemical fertilizers are highly subsidized. So how do you compete with chemical fertilizers?
Farmers are smart nowadays. They have also seen that chemical fertilizer has impacted their soil. The carbon content has come down from the soil. So what they do, whatever farmers whom we are supplying through our dealer network, we have seen that they are using both manure and the chemical, organic and the chemical. Maybe 25 to 30% they use organic manure, wherein the bed which they are making, they use organic manure, and then the regular chemical spray and pesticide they have been doing. And every time when they see results, slowly and slowly they are increasing the carbon content. We have done some study on the farms which are using our products since last 4 or 5 years. We have seen the carbon content in those soil has improved by 40%.
All right. Maybe we can first take audience questions, and then with the remaining panelists also, if there are less questions, we can ask the panelists as well. So maybe first we can take audience questions. Yes, sir. If you can briefly introduce yourself and then ask a question to a panelist.
I'm Hanumant Rawat from Uttarakhand government. I'm not expecting the answer right now, but this panel seems to be, exposed to the range of plants because Uttarakhand is the mountain state. And जैसे अभिरूप जी बता रहे थे कि ABCD of the CBG, आपने बताया closer to the feedstock. उत्तराखंड जैसे माउंटेन स्टेट है, नॉर्थ ईस्ट और JNK और हिमाचल, वहाँ पे 3-4 कंस्टेंट हैं. पहला कंस्टेंट है कि लैंड की अवेलेबिलिटी जो है, अगर 3-4 एकड़ भी चाहिए तो चलिए 80 नाली जो है वो देखो पूरा एक गांव जितना जमीन होता है उतना एक प्लांट के लिए चाहिए. दूसरा चैलेंज है कि मूवमेंट ऑफ द बायोमास और वेस्ट इज वेरी वेरी चैलेंजिंग. ओके, इज देयर सम वे टू हैव ए सम डिसेंट्रलाइज्ड मॉडल ऑफ ए 2 TPD फॉर एग्जांपल which can reduce or eliminate the movement of the biomass of the waste to some centralized place, or some way we can basically decouple the purification compression away from the biogas, so we can, at least for the hilly districts, we can think of a model. Because if the mountain states, they have this these kind of a project coming up, it will have a cascading effect for the plain districts, plain states. अगर गंगा वहीं पे गंदी हो जाएगी तो फिर झारखंड और बिहार और वेस्ट बंगाल में तो बहुत गंदी हो जाएगी.
Is any developer?
तो इसका कोई ABCD कोई फॉर्मूला है भट्टाचार्य जी?
Thank you.
Melu?
Yes, yes, please.
Sure. Well, गंदगी दूर करने का फॉर्मूला नहीं है, but I have a solution which can work there. What can be done is, from what I understand is कि your produce is less, hence the size of the plant will be lesser, smaller. Well, economies of scale says that, I actually agree with Mr. Adlakha that 10 ton se niche, you would be longer, for a longer period of years, you will be EBITDA negative. So that really doesn't work. What works is, and this is what the government has already started doing, just like your LNG or natural gas, you inject it into the national grid, in Andhra Pradesh maybe, in the KG-D6 area, and you take it out in Gujarat. That's what I'm saying. If the pipeline network is there, if the pipeline is difficult, then all is remain is the cascading. So, or else convert it into LNG, you produce CBG somewhere else where you are closer to the source, convert it into LNG, small scale LNG plants, liquefaction plants are there, which are making economical sense right now. And then you send it to your place, you know. So the cost of transportation will also be reduced because the energy movement is more. These can actually happen, and by LNG, I don't mean LNG by trucks. You take LNG by LNG tankers, rail tankers. That will be cheaper.
Thank you. Any other question? Yes, sir.
Yeah, very informed panel discussion. Thank you very much. I'm Naveen from representing Grassroots. I have a follow-up question what Mr. Hanumantrao was asking about the hilly states. Any of you might have an experience about pine needles as one of the feedstock for the CBG plant. What kind of challenges are there in the pre-treatment? Because on a hilly terrain, this kind of biomass is abundantly available, and I just wanted to see, your expert opinion about it. Like, how can we use it actually?
Which feedstock did you talk about?
Pine needles.
Is any developer working with that feedstock?
No. Can I take it?
I will add just, you can follow up with the cane trash also. I am very interested to know what kind of yields are available on cane trash. Thank you.
Sure. I can take both the questions. We are not working on pine needles, but I understand it is a difficult thing to, digest. But we are working with something similarly hard. We are working with cashew cells. So that's also very hard. Cashew, the shell of the cashew, it's a waste, right? Very hard. I don't think you can think of any machinery which can digest it, but we are doing it. So that is digestible as long as you send it to the digesters in a crushed form. So pine needle probably, if you can crush it. So see what happens in all these feedstocks. Let me just clarify one thing. It is organic matter inside it. The organic matter gets converted inside the digester. Problem is, and this problem is with paddy also, it is there with pine, pine needles also. Problem is, there is a wall around the organic matter. It's just like a fortress, fortress ka diwal todna padega, then we can go and conquer it. So lignocellulosic wall has to be broken. How you break it is the challenge. You extrude it to break it. There are various technologies. You can do steam explosion. There is electrophoresis. For those of you who know, you can actually pass a high voltage electricity, it breaks the wall. The moment you break the wall, send it to the digester, digest it. So that challenge is the only challenge that you have with all these difficult feedstocks. Coming to cane trash, we are using it in multiple plants. We are using it in Navsari, we are using it in Baroda. Very easy to digest, not an issue. Getting around 8.5% yield. Right? You have to only soak it for 3 hours. That's the challenge before you extrude.
Thank you. Mr. Adlakha, I think you also have experience with cane biomass.
Yeah, but before that, I would just want to kind of answer his question, and I just had a suggestion, right? See, typically a bio CVG plant, right, has got 2-3 parts of it, right? One of them is your pre-treatment, right? Then there is digestion, and then there is gas and what you call the fertilizer, the LFM or the FOM management, right? Typically 4-5 parts of the plant, right? Now in places of hilly areas, right, what can be a suggestion is that you can collect the bio waste, right? You create smaller digesters, right? And what you do is you convert that feedstock into just slurry, okay? Once the slurry is produced, right, after maybe keeping it for 15-20 days, it will decompose, ferment on its own, right? You transfer that slurry into the plains wherever the land is available for gas management and so that the economies of scale are at least there on the gas management side, right? All what you need to do at various villages on this thing, you just need to manage the fermentation and the slurry production of whatever waste you can, whether it is farm waste, whether it's agricultural waste, whether it is pine needles, whatever, right? Or most of it is easily decomposable, right? You convert it into slurry and then you just transfer slurry, let's say from the hills to the plains where let's say 5 or 8 acres of land is available where the nearest plant is. You push this into the digesters there and then you use the slurry for gas production, right? So that might help solve the upstream issues on waste management and everything.
Okay,
right?
thank you. Can we take some other question? If you have any follow-up questions, can you please take it in the networking break? Yes.
Good afternoon. Myself, Arunachalam from AVMI Green Ventures. I've seen many of you are using digestion method. Anybody using the gasification to produce the biogas?
Mr. Pathak, if you can take it.
So there is a slight difference. When we go for gasification, the product is CO and H2. We call it as a syngas. The technology what we are discussing is biogas technology, where the product is methane plus CO2. So after during the gas processing, we remove CO2 and make a methane rich, which we here calling as a CBG, which is 96-97% methane. In biomass gasification, we have not installed and operated. We have studied it, but the product is different. The product is syngas, CO plus H2, which has other use. Either it can be used for power production or it is a good chemical precursor for multiple reactions, which can be taken up further. But yeah, the simple answer is, as of now, means we are using anaerobic digestion to produce biogas and methane, not gasification to produce syngas.
Thank you. Next question, please. Yes.
Very good afternoon to all the panelists. Myself, Dr. Atul Kumar from Terry School of Advanced Studies. So basically we understand that ensuring the continuous supply of a good quality feedstock are the biggest challenge that we see. And I'll talk from a municipal solid waste point of view because obviously there are trade-offs associated with it since we require a lot of pre-treatment. But certainly, usually we don't pay any gate fee with the municipal solid waste. So there are trade-offs with this particular thing. But as I'm experienced in this particular sector, you all panelists, I want your opinion for the newcomers, whoever wants to come in this sector, that how they can ensure a good quality feedstock, because you all guys are experiencing challenges in ensuring that particular feedstock. And if I can talk from New Delhi point of view, where as per my knowledge, there are no centralized CBG plants. So how come we can solve the problem, this wet organic waste problem in New Delhi? The second thing that I just want to get an opinion from you guys, like we did an impact assessment for one of the bio-CNG plant, and during the downstream side, we interacted with a lot of stakeholders, and we realized that there are a lot of hesitance with the FOM off-takers, compressed gas off-takers, we discussed with one of the gas filling stations. There was a dedicated filling station coming from this bio-CNG plant, and they said that usually government vehicles, municipal corporation vehicles, they are getting filled up, and there are a lot of reluctance from the private vehicle owners to get it refilled. So how do you see that, where we are right now from technology point of view, whether it is getting improved, how you can motivate the new players to come up in this particular sector, considering a lot of challenges in upstream as well as the downstream side?
Thank you. I think GPS Renewables has experience in MSW. He had a question on MSW-based feedstock, and what kind of feedback do you want to give the new players?
Okay. So I will take in reverse condition. So second question was about CBG quality. So I will assure you we are producing CBG at 96-97% methane, and it is being sold at retail outlet for current Geo plant, and previously in Indore it was sold to Avantika and other buses. So we have not received those complaints. Those complaints will come when the purity is not maintained, or sometimes there is a moisture issue. But when we operate biogas upgradation system, as I already told, at least for us, we have sorted it out. We have two-stage H2S removal followed by moisture removal, making the gas suitable for membrane system, and output of the membrane we are consistently giving 96-97% methane with that quality, minus 80 or 85 dew point and less than 5 ppm H2S. We have not faced any complaint for supply of CBG. Regarding MSW, which a slightly difficult problem to address. So what I will share is our experience in Indore. So in Indore, as we know, they have established very good system of source segregation. So when we built the plant, it was called as a source segregated organics, and we had a pre-treatment system which has segregation, trommel based segregation, or let us broadly call it as a size based segregation, followed by hammer mill, which is a wet hammer mill where we are preparing slurry, and there was a second layer of segregation to remove finer plastic kind of material. So at least with source segregated system, source segregated organics, we have a very robust system. It was scaled up. We are operating 750-800 ton of MSW every day, and the slurry coming out of consistent quality, 15% TS, around 80-85% VS, and gas production actually surpassed the expected yield. So based on Indore experience, I would suggest that source segregation is the best way. Once it reaches to the plant, and if it is not, it is having more than 50-60% of inorganic, it is just operationally expensive to remove and bring this organics up to the 80%. So for me, best Indore model works well. So nothing to say that MSW plant won't work. It will definitely work. There are technologies which has 2-3 layers of segregation, size segregation, then there's something called as a 3D segregation, and then finally it goes to the slurry preparation. Then we have sand settlement system in the hydrolysis tank. So these technologies are available, but if as we bring more and more contaminated, let's say for material to the plant, it will become operationally expensive.
Thank you.
I hope it answers.
Thank you. We have 2 more questions, I think.
Yes. Can I go ahead?
Yes, please.
Yeah, good afternoon. Actually, I have 2 questions. One is just kind of the extension of the previous question, and one question is related to one of our panelists mentioned that there is a gap of still that $10. So the first question is like that, we are talking about the, where from we can fill that gap. So my question is that, are we really, well educated in the system, that because we were talking about the purity, and again that it is kind of the recovery as well as the production. So in this front, like I mean to say that in the upstream, so what are the technological challenges we can, facing, and we can, fight them, and we can improve our margin, like this gap, whatever our panelist was saying, that Is it possible?
Thank you. I think Ashish Kumar, you talked about the $10 gap and how to fill that. He's asking.
I really didn't get the question very clearly, but I'll try and address. I mean, you talked about the challenges across the value chain, right?
Yes.
Yeah. Yes. Bridging the $10.
You talked about increasing the price of CBG, so he wants to know.
Yes, I'm saying that is a kind of suggestion as well. I'm saying that like, because I didn't see anything or I didn't hear anything like what unique thing we are doing in our, upstream in the purification section, so that I didn't hear anything like recovery. Because if our methane is going as a waste, if we are not recovering it properly, so I believe that maybe whatever the gap you see, that there is a chance that you can improve that and you can recover that. So what do you feel in that way?
Right, so I'll focus on the purification bit of it. Again, I think we have a lot of different, a buffet of technologies present over here for the gas purification. I can talk about what we do. We basically use amine scrubbing for the purification of the raw biogas. And with that, the methane losses are 0% almost, or less than 0.1%. This is what we are able to implement, because what I think you will hear from the other panelists also, typically the methane losses could range anything between 2 to 3% minimum, right? But on practical ground level situation, I really don't know what are the factual details over here. So from a purification point of view, we are able to maximize the extraction, right? I mean, yes, it involves a higher capex. It also has a higher opex, but this is the standard we follow. And I will also take the downstream topic over here from the previous gentleman over there. The reluctance for the gas adoption used to be there before the BIS specifications were revised. Earlier specification was your methane content has to be more than 90%. So when 90% was the benchmark, us situation mein, yes, we had also heard a lot of issues which were, coming up. But now with the revised specifications of 95% plus, there is absolutely no problem as far as acceptance is concerned for the gas. And also there is no reluctance on the adoption of FOM and LFOM also. But yes, the issue is it is very seasonal demand. It is not happening consistently on a daily basis. So FOM gets accepted during your post-wheat harvest, April, May. Then you will have a small window which will come during October, November. Then you will have another window for whoever is doing a third crop. It comes around Jan, Feb ke aaspas, right? So, which basically means you need to be prepared from supply chain and a cost structure point of view that you have to store the FOM also for a couple of months before it goes back to the farms.
Thank you. We have time for just one question. Yes.
Yeah, thanks so much. This is Prashant here, and I'm from Eneo Gas Engines. My question is mostly on the OPEX side. I think, Mr. Ashish, you talked about, the OPEX is about 65, 70 rupees. Which I would like to have a little bit more, because if you talk to some of the OEM of suppliers, they tell you about 35, 40 rupees. So from a person who wants to do these projects, it's little not so clear. What is the OPEX? Is it 65, 70, 35, 40? So if you could throw some lights, please.
See, I have talked only about what we have experienced. I do not want to make a generic statement across, but let's be very rational about it. Your major cost component here is feedstock. Now, for example, if you are running a press mud plant and you own the feedstock, then of course you will have a very different cost structure, right? As compared to let's say 4 टाइप के feedstock हैं, animal waste है, press mud है, municipal waste है और agri waste है. Of the 4, the most expensive to acquire is the agri residue. And paddy, amongst all of this, is the cheapest. I have not even talked about wheat and sugarcane and other feedstock types, because let's say, I'll give you 2-3 indications over there. So paddy, we talked about yield 11 to 12%. The feedstock cost is ranging between 2,500 to 3,500 rupees per ton. Not only collection cost but also storage cost throughout the year, right? If you take wheat, for example, this cost can almost go up by 30 to 40% minimum, because you have to compete with the fodder price, right? Agar fodder price jis saal toot gaya, then yes, you can acquire it, but otherwise not. So it's an opportunistic feedstock, right? Cane trash, but you get a very good yield from wheat. The yield will be anything between 13 to 16%. Again, from personal experience, not theoretical inputs over here. With cane trash, we get a yield of anything between 12 to 14%. Slightly more expensive than paddy, right? So you will always have to manage between the yield as well as the cost of acquiring the feedstock, because this is going to determine the entire OPEX, right? Your energy cost is flat, right? In the sense, electricity rate to change nahi ho rahe hain regularly. It is depending on the quality of the feedstock. If the feedstock quality is bad or, mediocre level, then you will end up consuming more energy in converting it, right? In stable state, 2.5 to 3.5 units is a very optimal level of energy consumption to make 1 kg of gas. Maintenance of the plant is your company's standard, right? How well you are able to maintain it, right? And then you have the manpower cost. So yes, we can have a variation of plus minus 5 rupees here and there, right? But this 60 to 70 will not become 30 or 40. That 65 can become 60, or maybe it can go 2-3 rupees higher, but this will not change significantly if any of these 4 types are significantly changing.
Thank you. Thank you, Mr. Kumar. Thank you. We have one last question, but request you to please keep it short and the answer also
yes.
very briefly.
Hi, yes. This is Manish Dapkara from EK Energy Services Limited. So my question is, what is the calorific value loss before digestion and after digestion of the biomass that is being used in the CBG plants?
Mr. Adlakha, if you want to take it.
Manish, I would not be able to kind of comment on the exact number, right? But it has a few variables which you would need to consider, right? The amount of time where the feedstock is lying open in the field and it's stored, right? That will also be a determinant how much of calorific value it loses, right? So that's one. The second is the fact that how efficiently are you processing it, right? For example, if you put the let's say a paddy into a paddy kind of cut paddy or whatever, you put it into through a BHS grinder versus an extruder, you'll probably lose more one versus the other, right? So it really depends on, again, to summarize, how much time you've actually cut it and stored it in the field or wherever, how fresh it is from the field. And the second is how efficiently have you processed it. So those would be the two determinants.
Okay. So post-digestion, it should be in the range of 2,200 to 2,400 kilocalories post-digestion. And pre-digestion, it should be roughly about 3,500.
Okay. Thank you. Mr. Bhattacharya, you wanted to add a number?
No, I think he's right. We are talking of VS destruction here, the volatile solid destruction. So it's usually in the range of around 60 to 66% inside the digester. So roughly 40% loss.
All right. Thank you. I think with this, we can end the panel discussion. It was a very interesting discussion. A lot of important points were shared by the panelists, and a lot of interesting questions were also taken by the audience. So thank you, everybody. A big hand for all our speakers. Thanks.